Hello, and welcome to this edition of the CSIX podcast series. In this episode, CSIX subject matter experts will conduct a roundtable discussion of the Rust programming language as a means to address current software development and program security shortfalls.
Well, I'd like to welcome everyone to the first of the series of software engineering-based Code Corner roundtable discussions by the Cybersecurity and Information Systems Information Analysis Center, or CSIAC. My name is Corley Patch, and I'll be the moderator for this podcast. Today we'll be talking about the challenges and benefits of using a new programming language called Rust, and how it can fundamentally improve resilience and survivability of the software-intensive systems that we use today. The DoD IX are sponsored by the Defense Technical Information Center, and one of the IX objectives is to bring industry, academia, and government together to solve hard technical problems. With the support of DTech, we were able to organize this Code Corner discussion to engage in subject matter experts from all professions that are addressing the current and future challenges involved in software engineering and cybersecurity. During our time together today, the participants will share their information based on a series of questions and provide their perspectives and approaches that they've taken, issues that they've encountered, as well as lessons they've learned. So I would like to introduce two software engineers, engineering/architecture subject matter experts, Dr. Jim Fossett and Mr. Mike Corley, to talk briefly about challenges and benefits of Rust. Dr. Fossett is a teaching professor emeritus of computer engineering at Syracuse University. He has extensive experience in industry and academia. In 1991 to May 2019, Dr. Fossett taught a series of graduate software design courses focused on methods of strategies for design, development, and management of large and complex distributed software systems. Prior to that, he worked in various roles from General Electric Company, including advanced engineering training assignments, systems engineer at Electronics Laboratory, and developer of manager in Radar Systems Department. As he taught as an adjunct in a variety of graduate electrical engineering courses at Syracuse University. Mr. Mike Corley is an R&D associate at Quantarian Solutions Incorporated. He supports a variety of contracts from the Defense Technical Information Center, the Cybersecurity Information Analysis Center, and the Air Force Research Laboratory in Rome, New York. Mr. Corley has more than 15 years of professional experience in software architecture design and software development and systems engineering, focusing on applications of computer networking and cybersecurity. Mike received his master's degree in computer engineering from Syracuse University in 2011, and he has recent interest in next generation cloud enabling services. Good morning, gentlemen. Thank you for your time here today. And what I'd like to do is introduce a series of questions today on this to spark conversation, and we'll move from question to question when we're ready. Sound good?
Great. Sounds great.
All right. Well, then the first question is, why was Rust developed, and how do you see it improving software-driven capabilities in the near and distant future? Dr. Fossett, you want to start?
Yeah, sure. Rust originally was started by a fellow by the name of Graydon Hoare while he was working for Mozilla. Rust in its current version was released in 2018, and in its current release form, Rust's raison d'etre is building safe, reliable systems. It's a system programming language designed for performance, but designed to deliver that performance in a memory safe and data race safe form. And that's sets it apart really from all of the other major current programming languages. They all can support safe development by convention, by care in the constructs you use and the way you use it. Rust provides safe operation by construction. Its compiler seeks out and won't allow you to build systems that have memory unsafeties or data race problems. So,
Very cool. Mike, do you have anything to add about that?
I would add to just for context, Corley, that a lot of my interest in Rust was made aware. Now I'm following some of Dr. Fossett's efforts and looking at the trail he's leaving behind as he develops out some ideas. And I come from, as a student of Syracuse University, and what I've done professionally, I've used a lot of C++ programming in my time. And what Dr. Fossett's indicating really is that you have these facilities in the C++ language that give you the conventions to build safe and really solid code, but it's very hard in a large system to make sure or to adhere to those conventions in all cases. It's almost impossible that you don't have cases where bugs and those data race and safety issues that Rust solves work their way into a even well-written C++ program. I mean, all of us have seen that or experienced that. So I agree. I think Rust is very interesting, and it's going to really pave the way to solve some problems that really haven't been addressed effectively in the past. And one of the difficulties is it takes some effort to get started with Rust. The model and what's involved in being able to build code. There are some, pain points to get over, as Doc puts it, and I agree with him. I'm looking at some of the things that he's invested in and building the stories in his. You can go to his site and look at the Rust Bites, and he's really helping people to get over some of those pain points. He's helped me to get over some of those, and I've been working software for some time. But it's very exciting with what's coming and some of the new approaches to overcoming some of those traditional challenges.
yeah.
Very cool.
Let me elaborate a little bit on Mike's comment. The real issue with the other major languages is not their deficiencies, but that because they do things by convention, as Mike has said, when you're building several 100,000 lines of code, 1 million lines of code, it's almost impossible to guarantee that you don't miss in one, 2 or 3 or 4 or 5 lines of code out of that 800,000 lines of code. How are you going to guarantee that you adhere to all the conventions? And the answer is you can't. You
Right.
can't. There's no way to do it. The only way you find them is after the fact, and you really don't want to have to look for that stuff after the fact, because you may realize that you have a problem, but have an extraordinary difficulty in finding it. And so one of the big advantages is that right at the beginning, you find out, because the compiler won't build the darn thing until a lot of those problems are fixed.
Yeah.
There's a couple of other things that I like a lot about Rust. Rust. I have written software in C++ for more than 20 years. I really like the C++ language and environment and tool set and all that sort of stuff. Lots of good stuff there. And I enjoy writing code. But Rust has, grew out of the people that designed Rust work from the C++ community, and they retain the very best part of C++, and that's a lot of stuff.
Yeah.
But they added their own clever twists on top of that, really interesting ideas on top of that to attack the memory and data race issues in that code. So there's other things too. For example, I look at the Rust libraries, and they seem to me, like the Goldilocks principle. There's not too much and not too little. The libraries have a lot of functionality, a lot of good functionality, but they don't blow you away with this enormous gob of stuff that takes months and months and months to figure out. They're lean, but their coverage is surprisingly good. They've been very well thought out, in how they were put together. So I like that a lot, and I like their build system. They have a build system based on a tool they call Cargo. That is a package manager and a builder and an executor, and that just turns out to be very, very effective. I like Cargo better than any build system I've used. I've used some really good ones. I really like Visual Studio and the way it works, but Cargo is just easier to use all the way around. So.
Yeah, and you mentioned the word build, which is key. I've seen this, especially the cybersecurity field for the last 20 years, is always like, we got to build this stuff in, not bolt it on. And I truly believe that things like projects like Rust are getting after that very problem. And I was wondering if you'd ever seen kind of an example of where where this Rust is building stuff in where it prevent problems down the road in terms of unauthorized access to memory and those types of things.
Because I've been an academic for so long, I don't see all those kind of, I'm not teaching in the security area, so I don't see all those vulnerabilities. But what I can tell you for sure is that I find in my own code, in the code I write, that it's a little harder to get going with Rust because Rust is keeping your ensuring that you don't make any of the mired mistakes you can make with memory and data race issues. But once you've got a design flushed in, you got the structure there, I find it much faster to develop in Rust than even C++. I'm very familiar with C++, but I find I write, once I get past getting that first structure to compile correctly, it's much faster just because I do far less debugging when I write Rust code than I do with, I've got lots of experience with C++, some experience with C#, and so on. I've written code in lots of different languages, and I've never experienced a situation like I am now with Rust, where things, once you're going, it's like you're on a bicycle going downhill, baby.
Nice.
It seems to work. So,
what do you think about it, Mike?
You had commented in some of our past discussions, Doc, that you find that you do well without even the use of a debugger because the compiler's error messages are so good and so on point.
Yeah. For those who are tuning in, who haven't used Rust, Rust doesn't come with a native debugger. You can use the GNU debugger, and there's lots of debugging tools you can use. None of them are as nice as the Visual Studio debugging tools. Microsoft has had a lot of years to work this out, and they're really good. And I expect probably eventually there'll be some tools like that for Rust, but I don't see it as being at first I thought that was going to be kind of a showstopper for me. There isn't a really good visual debugger. I use that so much in Visual Studio, and what I'm finding is I don't need to use it when I'm writing code. Every once in a while I say, gee, I wish I had, but that's rare, very rare. Most of the time, the errors tend to be compilation errors, not execution errors.
Yeah, that's what I was going to comment, Doc. If the model is such that you're shifting a lot of those errors that were traditionally, caught at runtime, if you're shifting them to compile time, because you're really not building until that's great.
You really want to find them there because it's a whole lot cheaper to find them there than it is to go back and look through the needle in the haystack.
And we've talked about this in classes and some of your courses, your engineering courses in past, some of the research that's gone into, some of the static type analysis you do on traditional code in order to find some of those things at compile time to help assist the compiler with, maybe you don't want to build this, maybe you don't want to build that, more of a linter kind of a thing, but with some Rust is just doing that for you. And in instances where it can't do enough semantic unraveling, so to speak, it panics, right? It just won't let you do it. So if it will build, it just won't let you do anything that is essentially memory error prone, because it'll panic. And
Yeah.
that's what webinars that you did.
The
Yeah.
panic is the runtime lowest level of defense for error handling, and you don't want things to panic. And there's lots of tools to avoid the panics, but in the last analysis, panics refuse to give you access to memory that you don't own. There's just no way to do it in Rust, and that's absolutely not true of the other languages. With C++, you can have dangling pointers and index overruns and stuff like that. And you can overrun your index. You can index outside of an array. But in Rust, you get a panic, you can't get access to the memory, where in C++, you can get access to the memory, you can use it. You might be using it inadvertently, getting totally incorrect data, filtering into your program and being computed as part of the final result, and you'd never, you just scratch your head and say, why are these results looking like this? I shouldn't.
That's cool. And we're kind of rolling to the end of our time, but it's funny thing about it is I asked a series of questions which you guys have already answered. What are the key differences in programming in Rust as opposed to its close relative C++? And how will Rust save time and money? And what kind of factors Rust makes worth learning and using, which you've covered all. And so it's kind of appropriate to just go down to the end of this, because we've been talking about how this actually have been able to not have to lean on the debugger as much. And it kind of sounds to me like a kind of a lean manufacturing thing where, they talked about the Toyota plants. They'll go out and look at other plants, and they got a guide down the line. Oops. Yeah. Well, unfortunately, hopefully I'm getting audio back. But, down the line, they're actually hitting a piece of the car with a rubber mallet to fix it. Whereas it looks like we dropped a member, and we got Mike with us. So the show will go on. So long story short in that is that fixing it down the line is much more expensive than fixing it up front. And rather than seeing it, the rubber mallet would be the debugger. And going up the line, if you've got it fixed in the first place, you don't need the debugger as much to fix the problems that would have been created. What do you think about that, Mike?
Yeah, I think that that's absolutely true, Corley. When you start talking about the Agile model, or even the extensions of the Agile model, the DevOps model, which is really about that, the whole iterative idea of engaging folks and solving problems in an iterative way. It's really about engaging the entire organization and being able to leverage all of the insights of the different key players in the path of the software development lifecycle. And the extension of that is this idea of DevSecOps, where you're mapping security onto each of those points in the software development lifecycle. And what you're going to find with Rust is particularly those areas in a traditional programming environment where you do have to go back and solve and fix, and a lot of those are going to be preempted because you're like Doc had mentioned earlier, you're solving those problems or preventing them. They're worked out by construction rather than by convention, where later on they manifest themselves. You're just moving a lot of that left, if you will, to the compilation phase. So I think it has an effect on enhancing the efficiency of the entire life cycle of the development right up into production and all of those phases that you're making reference to. So
very cool.
That's what I think.
Well, awesome. Well, I appreciate it. I know it's been a short time here. We could talk about this all day, and I guess we'll have to wrap it up for now. But I look forward to continuing Code Corner type discussions, and we'll get some different perspectives in, and we'll do some fast lightning round discussions. And sorry we lost Dr. Fossett there, but it was great input while we technically had him. And I thank you both for your time today. But that's about all we have for time today. Thank you very much for offering your time and expertise, of course, and your perspectives. This really does make it all happen. And basically trying to understand Rust can fundamentally improve resilience and survivability of software-intensive systems. Mm-hmm. For details, detailed podcasts on Rust as well as C++ programming language, please search Google for CSIAC and Rust, and you can go to the site at https://www.csiac.org. And we hope that you enjoyed this podcast, and we look forward to another one in the near future. And above all, have a great day.
Thank you.
On behalf of the CSIAC, we would like to thank you for viewing this podcast. We hope you found the content informative and useful. If you would like to provide feedback or comments, please visit our website at www.csiac.org, where you can also find additional content to review. Thank you.
Did you know that CSIAC offers free monthly webinars featuring experts in the areas of cybersecurity, software engineering, modeling and simulation, and knowledge management? Come see leading industry professionals talk about industry practices and leading research. Make sure to visit www.csiac.org/webinars in order to subscribe to our mailing list and see when the next webinar series is available. There you can also watch previous webinar series to catch up. Visit www.csiac.org/webinars.